Greetings, students. We'll discuss practice test 3 today. Question 1. So describe the transformations. So we're looking at y equals ax minus h squared plus k. So this is up and down, the last number. So this doesn't have up or down motion, this doesn't have up or down motion. So we can cross out anything that says up or down here. Not A, not B, not up and down. Same thing here, no upwards motion there. Alright, this is left and right. So we have to look at this, we have to say, is this left 2 or is this right 2? Well, it says x minus h, so it's the opposite of the number here. So because that's plus 2, it's going to be left 2. Option D. Now, if you're a little bit lost here, I'm letting you use a graphing calculator this time around. So you can take the calculator, turn it on. You can type in x squared as your first function, and as your second function, quantity x plus 2 squared. And you can look at these two and you can say, how are they different? There's x squared, and there's x plus 2 squared. X plus 2 is left 2 from x squared. You can actually use the trace key. So here's 0, 0, 0 for x squared. The vertex on the other one is at negative 2, 0. Negative 2, 0. So you can actually look at these and you can say, oh, yes, it's left 2. It's been translated left 2. Alright, the next one. That's left 1. So we got to go left 1, not right 1, left 1. Now compression horizontally or compression vertically? We didn't do compression horizontally yet. Compression horizontally is the other way around with x equals y squared. This is a compression vertically by 1/3 because 1/3 is A. So again, what that does, the A, it makes it point up or down. Up if it's positive, down if it's negative, and then it does compression and stretching. Stretches and compresses it. Stretches it if it's greater than 1. Compresses it if it's between 0 and 1. If its absolute value is between 0 and 1, or greater than 1. Alright, next one. This one you can't use a calculator to help you with. These other two you could use a calculator to help you with. This one you can't really. So it's up 1. So my base graph is in darker. This is up 1 from the base graph. And then the normal graph goes over 1, up 1. Over 1, up 1. But this one goes over 3. 1, 2, 3, up 1. So it's got a compression vertically by the same factor as this one did. Because it's over 3 up 1 instead of over 1 up 1. And if it was upside down, we would say it's stretched by 3. So if instead of it's over 3 up 1, if it was up 3 over 1, we would say it's stretched by a factor of 3. So again, that's a compression by 3 because it's over 3 up 1. Alright, so there's the first 3. That's from our notebook, from the parabolas in our notebook, which was 3.01. I think it was 3.1, and there was 3 sections of it. Yeah, 3.1. There's 3 sections of it. We talked about this if you want to go back and revisit it a little bit. And it was the vertex form of parabolas, specifically 3.1a, page 92. So if you had to review these first 3, this is from page 92. These first 3 are page 92. First 3 questions. Anyhow, you can also come see me if you want to after school. Alright, questions 4 and 5. It says, determine the real zeros, state the multiplicity of them. When you repeated zeros and describe them behavior. Sketch a graph. So I can use a calculator to help me find the real zeros here. So it's going between 0 and 10 in my grid here. So I can know that my zeros are going to be between 0 and 10 when I graph this. So I can do negative x to the fourth so negative x to the fourth minus 4x to the third minus 6x squared minus 4x minus 1. So my graph, here it comes. We can see here it crosses or bounces off the axis at negative 1. So I can actually calculate that. So I can calc maximum. Go to the left of negative 1. To the right of negative 1. And then take a guess in between. It tells me negative 1, 0. I know it's got a y-intercept at negative 1 because if I put 0 in, it's going to make all these 0. I'm just going to have the last one. And it has symmetry at its vertex here, so I'll put another point there. So this is my only real 0. So either it has complex zeros or it has multiplicity 4. So I can verify that this is the only real 0 and that it's not got complex zeros by doing synthetic division onto the polynomial and seeing what's left over from the synthetic division. So I know negative 1 is a 0 of this polynomial, so I can divide it in. And I can see the remainder. The remainder, of course, is going to be 0, but I'm talking about the polynomial remainder inside. So that's negative 3 there, positive 3, negative 3, positive 3, negative 1, and of course this last one is 0. So that's x to the third now, minus 3x squared minus 3x minus 1. I can attempt to factor that, or I can say let's divide negative 1 in again. And why am I dividing negative 1 again? Well, because I know it's got multiplicity 2 because it bounced off of the axis there. So I know negative 1 is another 0 here, at least multiplicity 2, because that bounced there instead of going through the axes. So here we go again. This will come up as a 0 again. I know it's going to come up with a 0 remainder because it bounced off of there. Oh, sorry. I should have used the smaller one. Should have used this one. Negative 1, negative 3, negative 3, negative 1. So I got negative 1, positive 1, negative 2, positive 2, negative 1, positive 1, 0. So there's my remainder. Negative x squared minus 2x minus 1. So I'm looking at this and I'm saying, does this factor to make more real zeros? And it does. If I divide by negative 1, I got x squared plus 2x plus 1 equals 0. Yeah, this is x minus 1 again. So it's got multiplicity 4. This one does. All 4 real zeros are negative 1. Multiplicity 4 of negative 1. Again, I knew it was negative. I knew it was at least multiplicity 2 because it bounced off of the graph there. It bounced off of the axes. Instead of going through, it bounced. So I determined it was at least multiplicity 2 from that. I divided it out with synthetic division to find out what's left over. And then I said, does this factor? And it's like, yeah, it does factor. And it factors with x minus 1, or x plus 1 again. So minus 1 for 2 more zeros there. All 4 zeros are negative 1, in other words. You don't have to find the non-real zeros here. It just says the real zeros. So if it did have complex zeros, we wouldn't have to list them like we do on the 10 and 11. All right, this one. I know one of my zeros is 0. How? Because these all three have x in them. This one didn't all three have x. This one has a y-intercept of negative 1. But these all three have x. So I know 0, 0 is a 0. So I can pull that 0 out, and then I can attempt to either factor it, which are left over, or I can do a quadratic formula. So when I take the x out of all three of those, I'm left with 4x squared minus 12x plus 9. left with this. So now I can attempt to factor this, or I can use the quadratic formula to find the other zeros, if they're real or not. I can also graph it on the calculator to find the other real zeros. Alright, so I'll do factoring here. Why am I using factoring? Because I can. If you want to use a calculator, you can also use the calculator to find the other real zeros. Use the original though. You don't need to use this one. Use the original. They will yield the same zero, but the graph will look slightly different. That's the issue. Alright, so we're using 36 to make negative 12. So negative 6 and negative 6. Both of my factors are negative 6 here, which means both of my zeros are the same. Negative 6 divided by 4, which is 1/2. 6/4 is 1/2. 1.5, sorry. 1.5. So that's multiplicity 2. Why? Because both of these are the same. Multiplicity 2. I got an x cubed, so it points up on the right. Down on the left, multiplicity 2, so it's bouncing here. Now I can use the graphing calculator again to verify my graph, or to actually do the problem if I'd like to as well, by typing it in. So here I've got the negative 4x cubed, or positive 4x cubed, sorry. 4x to the third, minus 12x squared, plus 9x. It's open, come in.
You just gotta pull, guys. It's always open. Come on in.
Okay. Can I drop this off?
Yep. So we have here a 0 at 1.50 and a 0 at 0. You see it on the grid right there. And if you want to find them, do second calc, 0, left bound, right bound, take a guess. There's the first one, second calc, 0, left bound, right bound, take a guess, and it'll give us the other one in a minute here, 1.5, come 0. Alright, those are a little bit longer, these two questions. Question 6, we're going to use a calculator to determine the maximum here. So we'll have to type this equation in, negative 16. This is the only one where you actually need the calculator. You actually have to use the calculator here on this one. The rest of these you can do without the calculator if you'd like. This one requires it though. Negative 16x squared plus 20.6x. We're looking at the maximum here, the top of the graph. Second calc, maximum. Left bound, so left of the top, right of the top, and take a guess somewhere in the middle. There we go. We're going to write down both values, even though all I'm looking for is the y, the 6.63. So 0.64, comma 6.63. So at 0.64 seconds, or 64 hundredths of a second, it's at 6 and 63 hundredths feet. It's the height of the arrow. Question 7, this is the quickest one on here. Is the degree even or odd? The degree is the superscript. This is even. Is the lead coefficient positive or negative? The lead coefficient is the first integer. This is a positive, or the first number, the first real number, first coefficient. And in the end behavior, it's positive even, so it's a smiley faced. If it was negative even, it would be a frown. If it was positive odd, it would be pointing up like a line. Positive slope, negative odd, pointing down like a line. Again, all I need is the graph here. You can also do as x approaches infinity, y approaches infinity, as x approaches negative infinity, y approaches negative infinity, if you want to write it out. Alright, this next one, number 8, says to factor it. This is a sum of cubes. So 27, negative 27 is negative 3 to the third, so a is negative 3. And 64 is 4 to the third, so a and b here. So what we're looking on here is page, and we're talking about factoring. On page 118. Warren. So we're looking at this sum of cubes, page 118, and then this as well, difference of cubes. But this one's sum of cubes because it's a plus in between. So this will factor as a plus b, so negative 3x plus 4, and then a squared, so that's going to be 9x squared, minus ab, that's actually going to be plus 12x, plus b squared, plus 16. There it is. You can check this work by multiplying it out. This is 27x cubed. This is minus 37x squared. Sorry, 36x squared. This is plus 36x squared. So those will be canceled out. This is minus 48x. This is plus 48x. So those will cancel out. And this is plus 64. So the x's canceled out. The 48x minus 48x, the x squared is canceled out. Which are these two? Negative 36x squared, positive 36x squared. Leaving us with this. This new item should not factor further. With the 16 and the 9 and the 12. Should not factor further. It's done properly. Alright, question 9. Find the other real zeros. So these always come in pairs, these roots. So, but I have the whole full pair here. So I have 2 plus root 10, 2 minus root 10. I got the full pair there. This one doesn't have the full pair though. Negative 3 minus 3. I got to write down the other root there. Because it comes as a pair. The roots and the negative imaginary numbers. Alright, next one, factor. So with the factoring, you can do synthetic division by trying to divide by 1 first, or you can factor by grouping on some of these. This one can be factored with groups. Pull an x out of the first group, x squared. So I pull an x squared out of the first group, x minus 3. Pull a negative 1 out of the second group, x minus 3. We have x squared minus 1 times x minus 3. So our roots here, positive 3 and positive and negative 1. Again, I could have used synthetic division there too. I would start off by dividing by 1. If I divided by 1, I would have been left with x squared plus 4x plus 3, I believe. Yeah. And then you could have factored that out into an x minus 3 and an x plus 1. To get your other two factors, negative 1 and positive 3. Alright, this one also factors actually. X squared minus 6 and then x squared minus 3. So this one actually has to be factored because if I tried to divide by 1 or negative 1, this isn't going to divide evenly synthetically. So what I noticed here is that 6 and 3, they make 9 and they multiply to make 18. They add to make negative 9 and they multiply to 18. So these are both going to be root factors. Add the 6 over. So my root here, plus and minus the square root of 6. And then this other one, plus and minus the square root of 3. That's for the other root. So this one had to be factored. This one I could have did synthetic division to find a root. This one I had to factor though. So it does say factor on these. Factoring will work for both of these. Grouping on this one because it's got 4 terms. This one's A times C factoring, but A is 1. So in general, factor these. When they say factor, this is a better way to do it. Alright, moving on to the back. Last few. Long division. This is actually synthetic division because x plus 6. So I actually don't have to do long division here. That's a minus 6 though that's dividing in, not a positive 6 because I want the 0. If I want to do synthetic division, that is actually possible here. Make sure we have all our terms. We got x to the 5th, x to the 4th, x cubed, x squared, x and constant. So we have all our terms. We have all 6. 1, 2, 3, 4, 5, 6. So 5th power should have 6 terms. And then we're going to divide. Breaking 5 down, negative 30, negative 4, 24, positive 4, negative 24, negative 2, 12, negative 2, 12 again, and that's a negative 11 remainder. So what you need to match here is that remainder, negative 11. And if you match that, you should be able to get it right. So we're looking over here, the remainder, negative 11. The other factors also match. 5, negative 4, positive 4, negative 2, negative 2, negative 11. See? There it is. It does say you have to show your work. So you do have to show your division out for me. Alright, possible rational zeros, P and Q. P is equal to 1. Sorry, P is negative 8. Q is 1. So 8 divided by 1 is my first one. Right there. Well, that's the only one that has 8 divided by 1. How did I get the 4, 2, and 1? Because the factors of 8 are 4, 2, and 1. 4 divided by 1, 2 divided by 1, 1 divided by 1. There we go. Pretty quick on that one. Alright, question 14. State the number of complex zeros. The way this is worded, it's just asking you to state the number of zeros. Just the total number of zeros. It's got 4. Matches the power. My TCH is power. So what's power for? Complex zeros can also be real zeros. So when I'm saying state the number of complex zeros here, I kind of crossed out the complex here because it makes a little less sense to most people to call a complex zero a real zero. But real is actually complex. Real is actually part of the complex number system. It's just where there's no I. So it's asking you it's asking you how many zeros it has. It's got 4. It's got 4 zeros, real and complex. Some of them are real, some of them are complex. So I'm not asking just for the complex ones. I'm asking for the total number of zeros. How many zeros it has, which matches the power. Alright, so here, I just want you to find the zeros. Find the zeros. You don't have to state the possible zeros because you're going to find the zeros here anyways. I gave you 1 0. So one of my zeros is negative 2. Start off by dividing by it. So negative 2 into 1, 7, 6, negative 28, negative 40. Make sure you have all your items. We got x to the 4th, we should have 5. 1, 2, 3, 4, 5 items. Bring it down. Negative 2, 5, negative 10, negative 4, 8, negative 20, and I knew this was supposed to divide evenly, remainder 0. So there's my remainders. Now I can attempt to factor this by grouping, or I can try to find another 0 by dividing by 1 and negative 1. So from here you can take 2 different options, 2 different steps. Attempt to find another 0 synthetically, or attempt to factor it. And there is no particularly one correct way to do this. You might have to do a couple divisions though if you attempt to factor this by finding the by doing synthetic division. You might have to do a couple divisions before you find it, because if you attempt to divide by 1, 1's not going to work here. So if I attempt to divide this by 1, 5, negative 4, negative 20, this isn't going to work. That's going to be 6, negative, that's going to be 2, there's going to be a remainder. 1 doesn't work. If I attempt to do negative 1, same thing's going to happen. So if you're going to do, this, it's going to take you a little while to find the other zeros, because the other zeros here are going to be 4 and negative 5. They're the 2 zeros, or 2 of the other zeros here. Anyways, so you can do this and you can find the other zeros. I believe it's 4 and negative 5 are the other 2 zeros. So let's try 4. And the same thing's going to happen on the test too. You might have to do a couple divisions here on this last one. It's going to take you a little while if you do it this way. And I'll show you the other way in a minute here. Nope, it wasn't 4. Let me look on my cheat sheet here what it is. Two. Positive 2. That's what I was looking for. Positive 2. 1, 5, negative 4, negative 20. So there's 1, there's 2, there's 7, there's 14, there's 10, and there's, yeah, there's 20. No remainder. Positive 2. So I got negative 2, I got positive 2. And then here I've got x squared plus 7x plus 10. X squared, 7x plus 10. And I can factor that into x plus 5 and x plus 2. This will factor. X plus 5, x plus 2. So my other zeros are negative 5 and then negative 2. So negative 2 has multiplicity 2. Multiplicity 2. There's 2 of those. There's my 4 zeros. So again, that might take you a while to find the real zeros if you're going to do that. Now, the other option here is when I got to, what step was it? This one right here. If I want to take that and factor that. X cubed plus 5x squared minus 4x minus 20. I can factor that with groups as well. I pull an x squared here out. X squared times x plus 5 minus 4 times x plus 5. And then I can have my zeros from that. X squared minus 4 times by x plus 5. There's my negative 5. There's my 2 and my negative 2. So I could also do it that way too. Anyways, come in if you want some help.